Okay, so in a linear programming question, we are still essentially doing the same thing we were doing with our inequalities questions, but we're having to build some inequalities from the statements they're giving us first. So let's take a look. Bernie buys X packets of seeds and Y plants for his garden. He wants to buy more seeds than plants, and this can be represented by X is greater than Y, X being the seeds and Y being the plants. X is more than Y. He also wants to buy less than 10 packets of seeds. So, if our packets of seeds are represented by X, then we know that X wants to be less than 10. If he wants to buy at least 2 plants, then he needs to walk away with 2 or more. So Y must be equal to or greater than 2. So we've got to practice being able to convert these sentences into inequalities. It's not too hard. And so those are my 2 or more inequalities in X or Y that show this information. That's done. Now, each packet of seeds costs $1 and each plant costs $3. So, the maximum amount he can spend is $21 and I need to write an inequality that demonstrates this. So, for every packet of seeds he buys, he's going to spend $1. So if he buys X packets of seeds, he's going to spend X dollars on those. If he buys Y plants, he's going to spend $3 on every plant. So his total cost on plants will be Y times 3. The total amount of money he's spending altogether will be these two things added together, and that cannot get bigger than $21. It must be less than or equal to 21. So of course we can write this more tidily as X plus 3Y is less than or equal to 21. So that's that thing done. Now they're drawing on the grid X equals Y, and they want to draw 3 more lines to show the inequalities and shade the unwanted regions. So my inequalities are X is greater than Y, then X is less than 10, Y is equal to or greater than 2, and X plus 3Y is less than or equal to 21. So, here we go. If X is greater than Y, then I'd be wanting to shade above, I'd be wanting to be interested in what's above that line, so my shading would actually go below that line. But let's not worry about the shading until we've drawn everything else. To get the X is less than 10 information on here, what I'm going to do is place X equals 10 on this grid. And so X equals 10 looks like this. Now I'm interested in X being less than 10, so the area that's interesting to me is over here, right? And the area I would shade is therefore on this side. To deal with the Y is equal to or greater than 2, I would first of all draw Y equals 2. This would be a solid line because I've got the or equals to. I'm interested in what's above it, so I would shade what's below it. Now to draw X plus 3Y equals 21, I could pick X values and work out Y values plus a couple of points and draw a line. Remembering that zeros are the most helpful numbers to pick, if X was 0, then we'd just be looking at 3Y is 21, which will give me Y equals 7. So when X is 0, Y is 7. And if Y was 0, then I'd be looking at X equals 21. So when Y is 0, X equals 21. That points over here. And I need to connect these two things together with a solid line because there's an or equals to in my inequality. So I'm going to try very carefully to draw that line. You would of course use a ruler. I'm interested in X plus 3Y is less than or equal to 21. Less, lower, below. I would be interested in what's below that line and not what's above it. So I would shade what's above it. So going through piece by piece, I'm interested in x is greater than y. That means I want my x values to be bigger than my y values. Now actually before I misspoke. I said I'd want to shade on one side, but I wasn't reading carefully enough. X is greater than y. Think about what this means. We want points where the x value is bigger than the y value. So they've done something which you might be tempted to call a trick question. If x is greater than y, that's happening over here in this area. Look at any given point. X is 22, y is 1, 2, 3, 4, 5. These are all the x values bigger than the y values. So if this is the x equals y line, I would want to shade over here. Because if I shade over here, then all those points are where the x values are smaller than the y values. And I want to shade where x is greater than 10. Okay, I'm interested in when x is less than 10, so I want to shade the bit I don't want, where x is bigger than 10. So I'd be shading over here. I'm interested in y being equal to or greater than 2. That means I don't want the stuff below that line, so I'd shade below that line. That shading's gone all the way to there, by the way. And finally, I'm interested in when x plus 3y is equal to or less than 21. So I'm interested in being below the x plus 3y line, so I'd want to shade above it. Now, you'll probably want to just confirm that you've actually shaded the right area. So if we pick some nice clear point in here, here is x equals 6 and y equals 3. And let's just run through those conditions. The x value is greater than the y value. Check. The x value is less than 10. Check. The y value is equal to or greater than 2. Check. And x plus 3y is 15, which is less than or equal to 21. Check. So I think I've got the right region. This is definitely worth doing, but of course, if you do all of your shading on that diagram and you realize you've done it wrong, you're going to have a problem. So maybe doing some kind of little sketch picture over here with all these lines on it before you actually commit wouldn't be a bad idea. Let's look at the next part of the question. It says Bernie buys 8 packets of seeds. And remember, it seems like a long time ago, the seeds are represented by x. Bernie buys 8 packets of seeds, so x equals 8. We want to know the maximum number of plants he can buy. So if x equals 8, then I'm looking in my region over here at any point where x equals 8. Now, we could buy 2 plants, we could buy 3 plants, we could buy 4 plants. This is why it's important to use solid lines for or equal tos and dotted lines for not equal tos. Maximum number of plants I can buy is 4. The total cost of these packets of seeds and plants, well, he pays $1 for every packet of seeds and $3 for every plant. So that will be $20. Okay, let's have a look at the next question. This is another question about shading unwanted regions, and having almost got caught out in the previous question, I'm going to be especially careful looking at these, although they all look like they're well behaved. They've drawn for me several lines, but they haven't labelled them. So let's go through and figure out which line belongs to which thing. This horizontal line over here goes through y equals 2, so that line is y equals 2, and this horizontal line goes through y equals 1, so that's the y equals 1. I'm interested in when y is less than or equal to 2, so I'm interested in everything below it, which means I would shade above it. to show the unwanted region. Shading unwanted regions is very common in linear programming questions because you want to be able to see the values which are interesting to you. If you're shaded all over them, then you can't do that. I'm also interested in when y is equal to or greater than 1. Greater than, bigger than, above 1. So I would want to shade the region I'm not interested in so I can see the region above 1. So there's those first two bits of shading done. Now I need to figure out which of these two diagonal lines is which. Now if we think of these as being y equals 2x minus 1 and y equals 5 minus x, it should be pretty clear by looking at the gradients and y-intercepts which is which. If y equals 2x minus 1, we know it goes through the y-axis at minus 1 and has a positive gradient. So that must be this line over here. Y equals 2x minus 1. This one over here, 5 minus x, don't be deceived, it doesn't have a gradient of 5. The number is the y-intercept, and the coefficient of x is the gradient. So the y-intercept is 5, and the gradient's minus 1, and that's clearly this graph over here, which goes through 5 on the y-axis and has a downhill slope. Less than 2x minus 1, I'm interested in any values below that line. So looking below that line, I would end up looking down at this sort of region in here. So my shading would get rid of everything above the line. Above the line is on this side. So most of that's shaded already. I'll just finish off that bit of shading over here. I want to be below, less than, lower than the 5 minus x line. So I'm interested in values underneath this line. I want to get rid of values above this line. So I will be shading above the line, like so. And so this is the region that I'm interested in. We've got one more question on inequalities, and then one more question on linear programming. I'm going to do those in the next video.